Recording in progress.
Hey there, everybody. Welcome back. We're doing statistics. It's fall of 2022 at College of Sequoias, and we are working in our book. It is 10.3. This is on hypothesis tests for a one mean sample. Okay, 10.2, we did the one proportion hypothesis test. And so a lot of it is very, very similar. In fact, the hypothesis test itself hasn't changed much. Remember, we've got 5 steps, and I think I'm going to recap them again because it can't hurt. Step 1 is to identify H naught and HA. Identify and label H naught, which is called the null hypothesis, and HA, or H1, some books and stuff does, which is the alternate hypothesis. Alternate, or it's like kind of like the new one too. The null tends to be the old news, the old idea, and we're trying to see if we can do out with the old and in with the new. As a reminder, H naught will have an equal sign in it somewhere, and HA is an inequality. It will either have not equals, greater than, or less than. And then step 2 and step 3 are kind of interchangeable. Step 2 is calculate the test statistic and p-value. The p-val. And step 3 is identify alpha, the level of significance. Step 4, we compare the p-value to alpha. If the p-val is too low or lower than alpha, we reject the hoe and we support HA. And if the p-val is not too low, which means it's larger than alpha, we do not reject H naught, and we do not support HA. And finally, step 5 is a conclusion generally made about the alternate hypothesis. The new or alternate hypothesis. It's okay. It's okay to mention the null. But you really want to say whether or not you're supporting the new idea. Give me a second to write that stuff down. If you need this up longer, let me know and I'll leave it. Otherwise, I'm going to move it and go on. So let's take a look at what's new for HR 10.3. So 10.3 was about hypothesis test for a one mean sample. There we go. So what's different about this one? H naught is going to be mu equals some specific value, a number. And HA will be mu does not equal that number. Does not equal that number. Mu is less than that number, or mu is greater than that number. Everything else is the same in the hypothesis test. Steps 2 through 5 remain the same. And since step 2 or step 3, depending on which order you put them in, is calculate the test statistic and the p-value. How we do this in StatCrunch is stats, t-stats, one sample, and then you'll either have with summary or with data. And we'll do an example of both. Okay, remember we do have some rules about the mean. So things that need to apply. Either A, n is greater than or equal to 30, or the population is specifically stated to be normally distributed. Or B, we got to check the critical value versus the coefficient, the correlation coefficient. And that's from the QQ plot. Will give us the correlation coefficient. That's R.
Yeah.
And the critical value comes from a table. Hello, welcome. And if this is the case, we want no outliers. Someone's volume's on. It's tripping me out. So you can check it on a box plot. So if I can get it all on one screen, shit, I probably can. If I do this. There we go. That way you can see H naught and HA in all its glory. All right, that's kind of it for the rules. We're just going to do some examples now. Well, there is one more. We'll come back to the whiteboard in a little bit for something else. But right now, what I'm going to do is I'm going to do, and this is available in the file section in Canvas. So if you want to follow along without like having to write down the whole problem, that looks terrible for the word Canvas. We're going to do the Math 21 lecture notes. I might say in class. Let me go look at it. So if you click on files, let me make this screen a little bit bigger. I'll shrink it back down. So you click on files, Math 21 lecture notes in class. I'm going to use this for a lot for the rest of the semester because it's got a lot of problems already in it set up and they're easy to go through and do in class. So I have it downloaded, and where we're going to start is you want to scroll down to where 10.3 is. It should say 116 in this lower right corner. Oh, that's a thin pen. 116 in the lower right corner. I'll give you a minute to get that worked out. See if I can make the text bigger for the lecture presentation. So I'm going to have another whiteboard on the side to take notes as we're going for what I'm going to do in each problem. So from Math 21 Lecture Notes in Class, the file name, Math 21 Lecture Notes. And page, this is effectively 117. We're going to do example 1. We're going to do examples 1, 2, and 3, and I think there's an example 4 I want to do. So this one is on the resting metabolic rate. Called RMR. And it says the resting metabolic rate of healthy males. I think I'll make a note of that. That seems pretty important. It's not just anybody, it's just males that they're talking about. In complete silence is 5,710 kilojoules. KJ is kilojoules. It's a unit of energy. Kilojoules per day. Researchers measured, so I'm going to write that down. I don't know what it is yet. So 5,710 kilojoules per day. Researchers measured the RMR of 45 healthy males. That sounds like a sample size. Males who were listening to calm classical music and found their mean RMR for the sample, so that's X bar, is 5708.07 with a standard deviation of 992.05. Well, this 5,708 looks pretty close to this 5,710, so I'm guessing that's the population mean. At the alpha equals 0.05 level of significance, that's important. That's one of our steps. Is there evidence to conclude that the mean RMR of males is different than 5,710 kilojoules per day? So that's the new idea. Is it different than? Oops, sorry. That would make this HA. That right there is HA. HA, the mean is different or not equal to 5,710 kilojoules. So H naught is the statement of equality one. That's got to be equal to 5,710. And the computer won't let us put kilojoules per day in, but I'll make a note of it so that when I make my concluding sentence, it makes sense. Now you can see the lecture notes has the rest of it, but we're going to walk through it ourselves. So that's step one, right? Right here, step one. And step two, since it's from the problem, I'll call this step two. Like I said, step 2 and 3 are kind of interchangeable. Label alpha. Step 3 has to come from my MATLAB. Or StatCrunch, sorry. StatCrunch. And it's in stats, T-stats, one sample. We don't have data, we have summary. So I'm going to use summary. Stats, T-stats, one sample. Every time I put it over one sample, it covers it. There we go. Stats, T-stats, one sample with summary. It asks for the sample mean. We have that right here, 5,708. The sample standard deviation is given at 992.05. And the sample size was given at 45. 45 is bigger than 30, so we don't need to worry about anything. N is large enough to be normally the sample distribution is normally distributed. We are doing a hypothesis test, so we're going to leave it clicked on hypothesis test. We are going to enter the value 5,710. And I want to make sure I use the right symbol, not equal to. That's the default one, so that's okay. And we click compute. So step 3 has some more information for me. My T-stat is my test statistic. And my p-value is 0.9896. Good God, that's really high. P-value caps at 1. So in step 4, we compare this to alpha. How does p-value and alpha compare? P-value is 0.986. Sorry, 0.9896. Alpha is 0.05. 0.9896 is bigger than. So p-value is not too low. Do not reject the hoe. And
That was funny.
Do not support HA. I think it's easier to remember than the p-val's too low, the null must go. That's just lame. Students aren't going to reject the hoe. Sounds great. If you want to make it keep it clean, you're telling Santa at STFU. No ho ho ho, Santa. All right, step 5, statement of conclusion. So I do not want to reject H0. I do not want to support HA. I don't want to support it because there's not enough evidence. So there is insufficient evidence. I'm going to add in the null hypothesis, even though we don't need it, to reject a mean, RMR of 5,710 kilojoules per day in healthy males. nor to support. All right, okay, I'm winging this, so this is going to sound funny. There's insufficient evidence to reject a mean RMR of 5,710 kilojoules per day in healthy males. So we can't support that the mean is different. Mean RMR is different. This looks bad. I don't like this at all. It's clunky sounding. It's too clunky sounding. Screw it. I'm going back. Like sometimes it's easy to word a sentence that's good. There's insufficient evidence to support the claim. The claim is that the mean RMR of healthy males is different than 5,710 kilojoules per day. I'm still lecturing, but you better text me a message about how well this conversation went before you go to bed. And that's step 5. Ta-da! I didn't label it, but step 5. You don't really need to label the steps so long as you do them. But I think in terms of, at least for a while, and probably on the final, you want to label them. That makes sure you know you hit them. And you show to me, like on the final, you show to me you know what you're doing. You can always verify in the StatCrunch window that you have H0 and HA put in correctly. It's always worth doing before you finish out the problem. Like if it was supposed to be mu is less than 5,710, and I just forgot to click because the not equals is the default, I can always see here that whether or not I have it correct. Okay. So I will clear that and turn off annotate. Okay. All right, let's you guys ready for another one? And then come down to example 2. Make this bigger. You guys ready? This one I can see it's got some data in it, so we're not going to be doing summary, we're going to be doing data. Oh, Isabella, did you just show up? If you
I did. I got out of practice.
Okay, if you did, what we're looking at right here, these lecture notes, you can find in Canvas if you click on Files and open up Math 21 lecture notes that are in class. We're on page 117-ish. Isabella is a frequent flyer during math lab or tutoring hours. Got to make sure she stays on top of it. All right, let's take a look at the next one.
Wait, you said it was located on the left side, right? The
What?
left that the notes you have to go through files.
Yeah, you click on files and just scroll down until you get to Math 21 lecture notes.
Math 21 lecture notes. Got it.
Got it? Okay, good. And we are
Okay, thank you.
on the next problem we're doing is on page 118.
Okay.
Okay, so it says, this is example 2, and this is on quarters in the U.S. It says, according to the United States Mint, the people that make the quarters weigh 5.67 grams. That sounds like some old kind of news. I'm going to write down mu equals 5.67 grams. A researcher is interested in determining whether the state quarters have a weight that is different from 5.67. So different would be not equal to. That sounds like we've got H naught and HA already. He randomly selects 18 state quarters, so n equals 18. With the following data. It's on the, I don't want to write it down, all 18. Data provided. At alpha equals 0.05 level of significance, is there evidence to conclude that the state quarters have a weight that's different than 5.67? That matches up with what I was saying right there. Not equal to or different would be not equal to. So remember, H naught always has the equal sign in it. HA has a different symbol. That is an inequality. And I'm going to try copying and pasting this. I don't know that it's going to work, but it's worth a try. I did. I wonder if I can copy and paste like that. Oh, look at this. I can. So on a Windows computer, if you highlight them by selecting the squares, if you hold down the Control key and hit X, it cuts. So Control plus X to cut. And Control plus V to paste. All right, I got my 18 numbers in there, and I didn't hand type them, so I'm less likely to have fucked them up. Always a good thing. Now, n is 18. So this is not less than or equal to 30. And it didn't. The problem didn't say that it was normally distributed. So we need to check the QQ plot and the box plot. Box plot for outliers. The QQ plot, we're looking for a straight line. And the correlation coefficient. If it looks straight enough, I'm not going to bother getting a table to look. Because it's just more work than I want to do. Because I'm lazy. But we can check the box plot. I'm going to draw boxes horizontally. And click compute. And I don't see any outliers. The shape looks pretty good to me too. It doesn't look like it's left or right, so I'm guessing this is going to be linear. But we got to check the QQ plot. I'm going to do normal quantiles on the y-axis. I'm going to add the correlation statistic. Oh, those dots are pretty close to the line. 0.986, that's pretty high. I think we're good to go. Good to go. So, stats, t-stats, one sample with data this time. You know what? I'm going to put this on this little rug right here so it doesn't spin. It keeps spinning because it's not smooth. And now, that was brilliant. That was a brilliant idea. Every once in a while, I even impress myself. One sample, we're going to tell it what column we want. The only column with data, thankfully. And we have mu equals 5.67. And then mu does not equal 5.67. And we come down to compute. I'll move that up there so it's out of the way. It's not really going to be out of the way there. There we go. All right, so what do I got here? I have t-stat. And maybe I won't write down as many as I did last time. I wrote down them all. The t-stat is 2.75. Let's go 3 decimal places. And the p-value is 0.0136. So up here, H0 and HA were step 1. Step 2 is identifying given information, alpha. And here we just did step 3. We got our test statistic and p-value. Step 4, we're going to compare the p-value and alpha. P-value is 0.0136. Alpha is 0.05. And the way you want to compare is just go left to right. The first decimals match up, 0, 0. Then I've got a 1 and a 5. 1 is less than 5. So 0.0136 is less than 0.05. That's just a reminder because I've seen students mess that up before. commonly mess it up. So the p-value is too low. The p-value is too low. We reject the hoe. And we support HA. And I've got HA listed up here. It was 5.67 grams, and we were talking about quarters in the United States. So step 5. This time there is sufficient evidence. We're supporting HA. There is sufficient evidence to support the claim. That the mean weight US, I'm going to put state quarters because those are the ones they measured. Is different than, that was the wording they used, different than 5.67 grams. I might even add in because the null hypothesis was the regular quarters. So, which is the mean weight for non-state US quarters. I don't know that I need to, but I think it helps clarify what was going on. Again, I can pull this information from the sentence. Is there evidence to conclude? No, there is sufficient evidence. Or yes, there's sufficient evidence to conclude that state quarters have a weight different than 5.67 grams. You guys ready for the next one? The next one was an actual test in the project. This was a project for students for an in-person class that was done. So example 3 was on COS students and Energizer batteries. So a group of COS students discovered a study that claimed that Energizer batteries, when used in a simple LED flashlight, will last at least 75 hours. Which is 75 or more. So I'm going to say mu is greater than 75. That's more. That would be more. To test this claim, students tested 25 Energizer AA batteries. And found that they lasted a mean of 76.6 hours, with a standard deviation of 4.43 hours. Does this data support the claim that Energizer batteries will last at least 75 hours at the 0.05 level of significance? All right, so let's go through our test ideas. N is 25. It is less than 30. We don't have any information to check to see if it's normally distributed or check the QQ plot or anything like that. But I have to assume Energizer batteries are normally distributed. I can't imagine them having a wild deviation from a normal. So we will assume that we meet test conditions. And so step 1 is identifying H naught and HA. HA is the easiest one to identify. It said mean hours of at least 75, so at least is more than 75. And that means everything is going to stay the same for H naught, but I put an equal sign in between. Step 2 is alpha. And it's given to us. Alpha is given at 0.05. Step 3 is a StatCrunch thing. We're looking for t-stat and p-value. So let's go over to StatCrunch. And check this. So we're going to do stats, t-stats, one sample. We don't have the data, so we have to do with summer. And they gave us the mean was 76.6. The sample standard deviation is 4.43. Sample size was 25. The mean is 75, and we're looking for mean greater than 75. We click compute. And record what we got. I got a t-stat of 1.809. And I have a p-value of 0.0417. All right, step 4. Step 4 is to do some analysis. We're going to compare the p-value, which is 0.0417, with alpha, which is 0.05. If I look at the first two digits, 0.4 is less than 0.5. So the p-value is less than alpha. The p-value is too low. We reject the HO. And we support HA. So step 5, this was the COS students' work. I'm going to reference them in my answer. The COS students collected enough evidence to support their claim that the mean let's say battery life for AA energizers, that's from memory. I want to see what the wording on it said. I want to kind of match that. To support the claim that the mean battery life for AA energizers is more than 75 hours when used in a simple LED flashlight. You guys ready for one last example? Then we'll talk about the project and be done. All right. So we're going to do example 4 down here, but it's discussing statistical and practical significance. And you can see it down there. I'm going to just tell you what it means to me in my words. So statistical significance versus practical. Significant. Gosh, all of a sudden I can't spell it. Cents versus practical. Significance. So the idea here is when n gets large enough, and the p-value is less than alpha, we say that this is statistically significant. But when n is super large, super duper large, the results may show statistical significance, but not really make sense in the real world. Significant. Wow, I just keep mangling this word, don't I? Significance. Like it's we have stuff and it's based on this sigma divided by the square root of n. But as n gets large, this gets really, really small. And so, like, the data may show something that's misleading. And I think the best example is to do it by example. So let's look at an example. It says the average age of a mother at the time of her firstborn child is 25.2. So mean age, or mu, is 25.2. To determine if the average age has increased, a random sample of 1,200 mothers is chosen. And we see that X bar equals 25.5. And the standard deviation is 4.8. And we want to see whether the mean age has increased. So we're checking to see our alternate hypothesis is our mean age is greater than 25.2. So H naught is the mean is 25.2. All right, so let's go look at it. Stats, t-stats, one sample with summary. The sample mean was 25.5. The standard deviation is 4.8. Sample size is 1,200. Mean was 25.2. And we're doing greater than. So I'm kind of going through the steps a little bit faster. I want to get down to where we got the p-value. The p-value is 0.0153. And comparing it to a standard alpha, p-value is less than the alpha, which means we reject the HO and support HA. So we are supporting the mean age is greater than 25.2. years. That's our conclusion based on the evidence. But the old news was the old information was the average age of a mother was 25.2. The new age is 25.5, which is 0.3 years, which is 3 or 4 months older. Is that really significant? Is that really larger, like enough to point out? It's not like 26 or 27 or 28 years old. It's literally 3 months older. So while this shows statistical significance, it's not really practical. Does that make sense? So 25.5 is not a lot greater than 25.2. All right, that'll be it for that. I do want to point out where the project is. I'm going to save that because I like the size of the text. Let's come over here and look in Canvas. So we have a project due, and it's due, I want to say, the first week of December. So if you come to Files, and where did I put it? Important Documents. So Project. It's in Canvas. And we're going to go to Files, Important Documents. And we're looking for Stats Project. Are you a suspect? It says spring. I haven't updated it. Maybe I need to. See if there's anything here I need to update. Doesn't look like it. I don't have the due dates listed in it. Oh yeah, I do. I need to update this. Because it's got spring due dates. So Stats Project. Are you a suspect? I will upload a fall version. And all that really has is different due dates. So let me load it back up and just quick walkthrough of what you're doing. Read it first off. It'll tell you where to get the data. And it'll give you I give you tips on how to deal with some shit. Some of the data is not the way you want it. So like read this and follow what it says. Okay. Then you're going to have some questions to answer. These are the survey questions you don't have to answer. The preliminary discussion questions you should answer though. It's like, what are your ideas without looking at the data? What are your ideas about what's going to happen with these 3 questions? Well, 2 questions. Question 3 is, how do I make the survey better? And you'll see it's organized into parts. Part A is on sampling. This is like chapter 1's information. Summarizing and graphing data is chapter 2. Descriptive statistics, finding the mean, the standard deviation, the minimum, Q1, that's all chapter 3. So a lot of it follows the chapters kind of stuff. It doesn't say chapters. And then you'll get down to where we've done part E, binomial distributions. That was chapter 6. Normal distributions was chapter 7. And I would relook over some of your notes because sometimes it's easy to forget. Like when we're doing some of this stuff, you need to divide by square root of n and stuff like that. Just glance through your notes when you're doing it. And you're answering these questions. Part G is where confidence intervals start. That was what, chapter 9? So this is where the new stuff comes in. Chapter 9, and there's a couple questions on hypothesis tests. Okay? And then a conclusion. Like, give me a conclusion. So you won't be able to do I or J yet. You won't be able to do I yet. H we just covered today. Average male height. So this is a kind of like a 1 sample thing. So you could do all the way up through H, and we'll be doing I in the next couple weeks. Again, that's in files and important documents. And right now it says, are you a suspect, spring 2022? I will upload the one that says fall 2022. Either tonight or tomorrow morning. Any questions?
I have more of a, I guess, general question. For the project, how much time would you suggest that we set aside to do it?
That's dependent on the student.
Right.
I'm going to say most of you have been doing pretty well. It's more of along the lines of, do you understand what's being asked? You could probably do each section in under a half hour.
Oh, okay.
Definitely under a half hour. Some of them are really short. Some of them are 5-10 minute sections if you know what you're doing. If you don't understand how to do something, you can always message me. Either email me or hop on Discord on the my server. Where is my server? And I have a stats channel. Or email me to ask me questions and say, you know, I got a question. Can we meet on Zoom? And I'll say, sure. Let's see when we can meet.
Okay, thank you.
Okay. Anybody else have any questions?
I have a few, but it's not on this chapter. I have a few questions
Okay.
on chapter 9.
Let me stop recording. Is anybody have any chapter or questions related to what we're doing now? All right.
Nope, I'm good. Have a good night. Thank you.
You too.
Recording stop.